Hello students, in this video we'll begin our discussion of partial derivatives. If we're given a function of two variables, f of x and y, we define partial f partial x at the point xy to be the limit as h goes to 0 of f of x plus h comma y minus f of xy all divided by h. And we defined partial f partial y at the point xy to be the limit as h goes to 0 of f of x and then y plus h minus f of xy all divided by h. So these expressions are referred to as the first order partial derivatives. These are the first order partial derivatives. Of f with respect to x and y. So the partial derivative with respect to x is exactly this limit over here, and the partial derivative with respect to y is this limit over here. So what are we doing when we compute partial derivatives? So when we compute partial derivatives, here's a remark. When computing partial f partial x, we note that we're going to treat y as a constant, as if it wasn't changing, because y does not change between f of x plus h comma y and f of xy. In both of these expressions, the y is constant. When computing partial f partial x, we treat y as a constant and compute a derivative as we ordinarily would. We'll do some examples shortly, but one other notational remark is sometimes, we're going to see this later, we will often write partial f partial x parentheses y, and that says that we're going to do the derivative of f with respect to x, so f is changing and x is changing, but the variable outside here is the constant. And this notation will come in handy when we start talking about constrained partial derivatives, because oftentimes independent variables x and y will depend themselves on other independent variables, and then they'll become dependent variables. So understanding when variables are independent and dependent is very important in doing these calculations. However, at a very basic level, if we want to do a calculation to find a partial derivative, it should follow the same rules for differentiation. So for example, if my f of xy was e to the x cosine y plus x squared, we could find partial derivatives of this function. We could say that partial f partial x would be, this would be partial with respect to x of e to the x cosine y plus x squared. Now, when we're doing an x partial derivative, we're going to treat y as a constant. So this cosine of y over here, that whole expression is just a constant. So we'll differentiate as we ordinarily would have e to the x times a constant. The derivative of e to the x times a constant is e to the x times that constant times that constant. And then I have to do the derivative of x squared. There's no y's there, so the derivative, the partial derivative of x squared with respect to x is just going to be 2x as I ordinarily would think about it. If we did the partial with respect to y, the partial f partial y, what we'd have is we have the partial derivative with respect to y of e to the x cosine y plus x squared. Now we're going to treat x as a constant. So if we did that, the derivative of e to the cosine y times x would be e to the x cosine y. And I have to do the derivative of x cosine y with respect to y. The derivative of x cosine y with respect to y is negative x sine y. And then when we do the y derivative of x squared, x is a constant, so x squared is a constant, so the derivative with respect to y of x squared is equal to 0. So what we'll have over here is we'll have negative x sine y, e to the x cosine y is my y partial derivative. Thank you very much.